Injection molding is the cornerstone of modern manufacturing, enabling the mass production of precision plastic parts. We can balance quality and cost in a number of ways, starting with material selection. Material cost can account for 40 to 70% of total production costs, so choosing the right material is critical. The first step is to avoid over-engineering, for example, by using polypropylene rather than engineering plastics for non-critical components. Polypropylene is relatively inexpensive and can effectively reduce material costs while meeting basic functional requirements. It is also a good idea to consider recycled materials. In some application scenarios, recycled plastics can be properly processed to not only reduce costs, but also not affect product performance too much. In addition, using simulation software to predict material flow is an effective means of reducing waste. Through software simulation, you can accurately grasp the filling situation of the material in the mold, so as to optimize the use of materials, reduce the excess use of materials, and control costs from the source. In terms of part design, a well-designed part can lower costs and improve quality. Simplifying geometry and reducing inverts and complex features can reduce cycle times. This is because complex structures require more time to mold and demold, whereas simplification improves productivity as well as simplifying the mold structure and reducing the cost of manufacturing the mold. Uniform wall thickness is also critical, as it ensures that the plastic shrinks uniformly during the cooling process, reduces the creation of defects such as warpage, and also reduces energy consumption. In addition, standardizing components is an important strategy. Avoid custom tooling costs by using common screws, inserts, or finishes. This not only reduces purchasing costs, but also increases production flexibility and interchangeability. Invest in high-quality molds. While cheap molds may save upfront costs, they often lead to defects and frequent repairs. The use of durable materials is key, such as hardened steel molds that last longer and can withstand more injection cycles during high-volume production, reducing the frequency of mold changes and thus overall costs. Efficient cooling systems are also essential, as proper cooling channels can reduce cycle times and increase productivity, while also improving part consistency. Additionally, it is wise to use 3D printed molds to validate designs during low-volume trial production, as this way design issues can be identified and improved in a timely manner before going into mass production, avoiding the huge losses associated with problems after mass production. Optimize process parameters. Fine-tuning machine settings can enhance efficiency and reduce scrap. Reducing cycle time is one of the core objectives, and by adjusting injection speeds, pressures, and cooling times, production speeds can be increased while ensuring part integrity. Automation is also a key trend, with the use of robots for part pickup and quality control, which not only reduces labor costs, but also improves the accuracy and stability of operations. Real-time monitoring, on the other hand, with the help of sensors and IoT systems, detects deviations in the production process in advance and makes timely adjustments to avoid costly defective products. Implement rigorous quality control. Preventing defects is cheaper than fixing them. Statistical Process Control, SPC, ensures product consistency by tracking key indicators such as size and weight. First Article Inspection, FAI, verifies initial samples against design specifications to ensure product quality from the production source. Root Cause Analysis, RCA, proactively addresses recurring problems such as shrink marks or burrs by analyzing the root cause of the problem in depth and taking targeted measures to prevent the problem from recurring.